Okay, so welcome back again. This is the video number 5, where we are going to do the main or the biggest test that we are doing today. And these are the regression models. And I'm saying it in plural because we're going to do 3 models. So let's start. So to calculate to calculate and to do the regressions, we need to go to analyze and then go to regression linear. That's what the type of regression we are going to do, a linear regression. Click in there. And then this will pop up. So pay attention. We need to do 3 models. And first we are going to do one simple model, as you saw in the pre-recorded lecture. The single model, the first model that is simple, will only have the dependent as global mindset and your independent variable, materialism. I am assuming that I'm doing the materialism group. That's why I highlight that. If you are biospheric group, put biospheric in there. Or maybe follow me and then see if you get the same results. Before you move forward, click on statistics and click on collinearity diagnostic. Do not forget to do this thing. And then click OK, continue, and then click OK. And then this will show up. And here, again, we need to go and check step by step. There are 4 tests that we need to do in order to make sure that we can conclude on something about our hypothesis. So let's start. The first test is the F-test, the model fit. We need to demonstrate that the model doesn't have any problem in how we created and how the numbers work. And that is shown in here. You see this significance? This number needs to be less than 0.1. So we have 0.002. That's very good. We passed the model fit test. The F value is significant because it's less than 0.01. 0.1. That is the limit that you don't want to pass. So that's good. We passed the first thing. And then we can move to the second test. This first test is extremely important. If it doesn't pass, imagine that this is 0.2, that is very bad. That means that you need to, you cannot do anything with this. You cannot even interpret that this model, we reject the hypothesis. No, we cannot do anything. Then you just finish. You say like, we calculated the F value, the model fit test, and it's not significant. We cannot do anything. We move to the next model and you finish, right? That's simple as that, you finish. That's bad for the analysis because you are losing a model, but it could happen. So just rebuild if that is the case. I mean, it's bad statistically, but it's not bad for you because you are showing what happened. So that's the first test, the model fit. We pass it. Then we need to go to the second test. The second test is connected to the R-square. The R-square tells us how much of the variance of the dependent variable is explained by your model. We will assume that we want this to be big because we want to explain how the dependent variable moves, but also we have to be careful because this is a social science. So it will be very difficult that we actually manage to capture a lot of the explanation of the variable with the variables that we have, with the model that we have. Imagine we will win a Nobel Prize or something like that if we manage to actually capture at a very high level, 100%, how to assess the global mindset. It would be crazy if we achieve something like that. So in social sciences, we will tend to have low R squares. So, and then how do you get better R squares? Usually with more variables. So as you can see, we actually have a low R square. It's only 0.028. So that means that our model, this simple model, explains only 2.8% of the global mindset. It's very low, but it also makes sense because we only have one variable. So here the rule for to pass this test, I will say is that unless your R square is virtually 0 or like 1%, we can move forward because in social sciences, then it's fine. And also because we have only one variable, so it's very difficult that we will have something bigger. We will see in other models, it will improve. But we also pass this second test. 0.2 is okay, it's not zero, so we can move forward. The third test is the multicollinearity test. So the multicollinearity test will be shown in here in statistics BIF. So make sure that in statistics BIF, you don't have anything more than 4. More than 4 means something is wrong. Here we cannot have multicollinearity because we only have one variable, so it will be 1. Don't really have a problem because we only have 1. We will see in the next model, we will test if there is something. If there is something, I will tell you how to fix it. But of course, we don't have multicollinearity problem in this model. We can pass. And then we go to the fourth test, the last test. So this test, first you need to check the significance, this in here, of your variable materialism. So materialism needs to be also below 0.1, less than 0.1, similar to this. So 0.002, that's very good. That means that this is significant. So we passed everything. And the last thing to check, we need to check the standardized coefficient beta and check the sign, because this will tell us if the relationship is negative or positive. And this last step, I think you need to know for the people who are doing materialism, how did you state the hypothesis? Now that becomes very important. If you state that the relationship between materialism and global mindset is negative, you actually support the hypothesis, right? Because this is negative. If you stated that the relationship will be positive, then you reject the hypothesis, right? So what happens for materialism? That's why I choose materialism, because it's a tricky one. It depends a lot on how you state the hypothesis. I think I have discussed with the materialism groups, and I think we agreed that it will be negative, but I mean, whatever you did in how you stated it, then that's the conclusion that you will build. If you stated the hypothesis as the relationship is negative, then uh, you are actually supporting. But if you say positive and you see here that is negative, then you reject. The same with the other groups. If you are doing the collectivism, make sure that you pass the four test, F test, multicollinear, no, F test, R square, multicollinearity, and coefficient. And just if you passed everything, make sure that you can that you can actually support or reject depending on the sign. So that's model one, the simple model, just with one variable. Now we are going to do the second model, and the second model is the materialism, but with our control variables, gender, age, year, blah, blah, blah. All of these, I think, are 8 variables. So let's add everything in here. Make sure you have your variable on the top, and then click OK. And now it looks like this. Let's do the same, the fourth test, and let's see if we made it work. First, we start with significance, 0.002. That's good. We passed the F test, so passed. That's for model 2. Second thing is the R square. You can see it improved by adding more variables. Now we have an explanation power of 5.4%. I mean, it sounds low, but we can move forward. In the end, it's good. In social science, we can survive. So 0.05. The next thing is to check multicollinearity. And so come here, BIF value, and then we are happy because it's less than 4. No problem with multicollinearity, we can move forward. And the final test with the coefficients. Let's find materialism, the variable that matters to us, significance. Significance is less than 0.1. That's also good. It seems that materialism is significant. That's good. And let's check the sign is negative. So it's the same conclusion as in the previous model. If you stated the hypothesis that the relationship will be negative, you support in model 2 too. So now you have two conclusions from model 1, from model 2, and both are consistent. Let's move to model 3. This is the last model that we are going to do. So now we are going to use the other variables, not materialism, because that's the one that you are working with, but let's use the other variables as controls. So collectivism, move collectivism there, biospheric, networking skills, and professional aspirations as controls. Just make sure you are not including materialism again, but include the other four. If you are doing biospheric, then including the ones that are not biospheric, wherever you adapt, and click OK. Let's do the test again. So, and pay attention to this because this model, we will all have the same results. We all had the same, it will be the same for everyone. The numbers will look the same. Each group will just have to focus on their own variable. But since we are using all the variables for everyone, these results will apply for everyone. So let's start. First test, the model fit. So, or F test. Significance needs to be less than 0.1. That's super good. 0.001, super good. That's fine. Let's move to the next. R square, the adjusted R square is 0.30. That's very good. Now you see, with more variables, we have 30% of explanation of the global mindset. That's very good. So we move to the next. The next one is the multicollinearity test. And we also don't have a problem. Now let me make a quick parenthesis. I explained this in the trustworthiness lecture. I also explained this in the pre-recorded lecture about quantitative research. But let me explain again. The multicollinearity issue is when you have two variables that behave very similar. For example, age and experience. That is a typical multicollinearity issue. If we add age and experience, we don't have experience here, but if we add that, we could have that situation. The older you are, usually you have more experience. So that will pop up in here. Age and experience will appear with high correlation, like something like 5 and 6 or something like that. If that happens, how you fix this is you remove one of the variables. Maybe you remove age and just keep experience. You remove one of the problematic and then you try again. And then in the new try, maybe you don't have the multicollinearity test. Just a parenthesis so you remember. But we don't have to fix anything. It works. And the final test for materialism, because we are doing materialism, I am assuming I'm doing materialism. Significance 0.001, that's also very good. And then materialism is also negative in the standard coefficient beta. It's negative. So again, it depends on how you stated the hypothesis, but the results are consistent. In model 1, so it's over here. Oh, here. In model 1, it was negative, but where is it? Kind of find here. It's negative. In model 2, it's also negative. In model 3, it's also negative and significant, and it passed all the tests. So the final conclusion for materialism, I am giving you the answer in your assignment for materialism. The final conclusion is that you have full support for the hypothesis if you stated that the relationship will be negative, right? If you stated the relationship will be positive, then full support uh, for rejection. You will reject the hypothesis because it's actually the opposite. So that's the final conclusion. But I think materialism is quite lucky because everything worked out perfectly. What could happen if, imagine, one of the other groups had support in model 3 and model 2, but in model 1, maybe in model 1 it didn't work. Maybe it's not significant or something happened. It's not significant in here. So you have support, and rejection. What is the final conclusion? The final conclusion is partial support because you have two supports and one rejection. So you can imagine what happens if you have two rejections and one support. That means partial rejection. What happens if you have three rejections? That will be full reject. Then what happens, because that's pretty nice, we have three models, so you will always have some majority towards one of them. But imagine what will happen if model one, in one case, model one doesn't work. This F test is more than 0.1, so you stop and then you move to the next model. You cannot reject or support that model, so that model is useless. And then imagine that in model 2 is reject and in model 3 is support. If that happens, so useless, reject and support. If that happens, then you have inconclusive results because you have one and one. So those are the possibilities that you can finish with the analysis of all of this. And now we have finished with SPSS. We are done with doing the calculations and also doing the interpretations. You also learn how to interpret the descriptive statistics, the correlation matrix, and also the regressions with its three models. So you learn a lot. The last thing to do, but we will do that in another video, is that if you copy paste this in your dissertation, it's going to look awful. It's very difficult to understand. You need to make it a little bit better. So I will now teach you how to move back to Excel with some nice tables that I will include also in Canvas. So I will teach you how to translate from these crazy things to Excel tables. And those tables are actually the ones that you will submit in your workshop 3 assignment. I will take a look at them and make sure that everything is correct. And then if you need to fix something, I will write it and then you fix it. But that is what you will do. But that we will do it in the next video. So now we'll stop in here.